No, you have to get those specific 8 questions right. I'm gonna look at everyone. There's only 14 of you. I can just go at every single one. Well, you'll see it on Gradebook when you guys log in. All right, here we go, guys. So this question is coming from UH, so we're going to do it together. It says sketch the region bounded by the curves y equals 2 squared of x, x plus y equals 8, and y equals 1. Then find the volume of the solid generated by revolving this region about the x-axis. Okay, I know, or at least I hope I know, I know you guys can find intersection points without a calculator with algebra. So to speed things up, I will let you use your calculator momentarily. So y1 is 2 squared, but okay, be honest with yourself. Do you know how this graph looks without the assistance of a calculator? So look, here's my grid. I know that it's 2 squared of x, so 2 squared of x looks like something like that. This guy right here is y equals negative x plus 8, so I know that looks something like this. And then y equals 1 looks like a horizontal line. So can you do that without a calculator? See, do you know what region they're talking about? They're talking about this region right here. Yeah, that little triangular kind of looking thing. And then I'm rotating this about the x-axis. And when you do that, it's going to look like, let's see. And then look, when I cut this, I kind of like the font being 2 instead of 1. When I cut this, I have a washer, but I want you to see that you're going to have 2 separate types of washers because they're dictated by different parts of the parts of the function, like different equations. See, on this washer that I drew right there in sky blue is dictated by the square root curve and the linear line y equals 1. And then once I pass this intersection where these guys intersect, now this one in burnt orange is dictated by the both linear lines. Do you guys see that? Because there's a gap. There's a gap. This is what was a solid. That's a good question. That's a really good question. How do I know they're washers and not circles? This is the solid that I'm looking at, or the shaded region, where all 3 of them they're bounded. See, it says sketch a region bounded by the curve. So I'm bounded by those 3 curves. So the only region that's bounded by those 3 curves is that I put in purple. Do you see that? And that is in purple, where am I rotating it about? About the what axis? The x. So everything between the x-axis and the line y equals 1 is hollow. So that's how I know that when I do this slice that it's a washer. Does that make sense, Espinosa? Okay. Now check it out, guys. So let me go ahead and type in this into y1, y2, y3. I really don't care about that graph there anymore. But let me get my calculator out. Oh, don't worry. It's gonna change. It's gonna change later on today. All right. That looks like, okay, y1, 2 square root of x, y2, I think it was x plus y equals 8, so 8 minus x, or negative x plus 8, whatever you think is easier for you. Negative x plus 8, and then y3 was 1. If you want to see that little region again, let me do it in standard mode. There it is. This is a region that is shaded or bounded by all 3 of those curves. Make sure that you know how to do this without a calculator. Now, okay, guys, to make things go fast, you can use your calculator to find the intersection, but I expect you to know how to do that. That's just basic algebra, right? So the one between the, I think, let's see, what was this? 2 squared of x and negative x and y equals 1. So I don't know, 1/5, 1/4. Second, calculate number 5 intersection. And then now you have 3 curves. So let me see. I'm going to move. Yep, I want that blue one. Enter. And no, not the red one. Not yet. I want the black one. So I'm going to scroll. Okay, there it is. A blue one and black one. Enter. And it says guess. So I'm just going to push enter. And there it is, 0.25. That's your first intersection. So on your paper, this intersection happens, the very first one is at x equals 0.25. And then the next one is the 2 square root of x and the line negative x plus 8. You can set them equal to each other and solve, but look, to save time so you guys can be fast, second, calculate number 5. You might actually be able to just look at the graph and see. It looks like it's like 4. Enter, and then enter for the square root and the red, and then enter. And there it is, x equals 4. So this point right here is 4. And then this is probably the easiest one of all to get. So you probably don't need a calculator for that. Negative x plus 8 equals 1. Just move 1 to the other side. That's obviously 7. X equals 7. But if you wanted to see it, look. Second, calculate. I'm going to put number 5. And look, check it out, guys. Red line and black line. And I'm not insulting your intelligence. I know you could have done this really easy just by looking at it. There it is, 7. Okay, so here we go. Chav, why did you do that? Between 0.25 and 4, my washers use specifically 2 distinct equations. Pi on the outside, integral, 0.25 all the way to 4. What's my big R? The distance from the x-axis to this 2 square root x curve. Do you guys see that? Giant parenthesis, 2 square root x, close it, squared. Minus, what's the little r? The little r, it always looks like it is going to be 1. Go ahead and put a square on it, guys, so the author, whoever is grading your exam, knows that it's big R squared minus little r squared. Plus, look at the burnt orange, and I should have color coded it, I'm sorry, guys. Integral, pi on the outside, from what to what? 4 to 7. What's my big R now? Negative x plus 8, close it, squared, minus, what's the little r? It's the distance from the x-axis to this curve. And that curve is negative x plus 8. This curve. See? Do you see what I'm talking about or no, Lavelle? Are you sure or are you just telling me that? Put the 1 squared, guys, so the author knows that you are squaring little r, and so you know that you're squaring little r. Cool or not cool? Look how the answer choices all have a pi in them. YouTube, if you're wondering why I'm whispering or talking real low, it's because they're testing next door. So I'm doing this by choice. I'm like going really low. Don't thumbs down my video, please. Okay. Here we go. I know you can do this real quick by hand, or not quickly by hand, but it might take you some time. You can use your calculator. Ready? Here, look how fast you can do. Notice all the answers were in terms of pi, guys. Math, 9. I'm not putting a pi. All right, guys, Lavelle, focus. 0.25 all the way to what? 4. And then I'm going to go, I think I had it in y1. So alpha trace y1 squared. And I don't really care about the 1. I can just go minus 1 squared myself here. And I know 1 squared is still 1, but put it in there. X plus math 9 from 4 to 7. And I want to say that I had it on y2. Alpha trace y2 squared minus 1 squared. Put an x on it. Push enter. Oh, that answer is not in there. Yeah, it is. Turn into a fraction, math, fraction, enter. And then what do I put on top? A pi. So look for 369 pi over 8. Do you see how we did it, guys? Okay, it wasn't that bad, right? So this is a question from UH, and there it is. So now you're seeing what you're dealing with. Okay. This is fun, especially for you art lovers. We're going to revolve around something that is not the x-axis or the y-axis. So check it out. It says, revolving about an x or y-axis aren't the only options. We can always revolve around an alternate horizontal or vertical line. Let's see how this will look. The region between, all right, guys, see if you can draw this. The region between the graph f of x equals square root of x and the x-axis between 0 and 9 is revolved about y equals 5. So draw. So here's my grid. Let me put it in black. We're just going to focus. I'm revolving about what? The y equals 5. So I'm just going to focus on quadrant 1 the whole time. So here it is. And here's 9. And I know that when x is 9, the y value is 3. This is the region. It says bounded between the x-axis. Okay, everything you see in red, I don't know if you can see it, but it's bounded down there. All right, I'm going to rotate it about the line y equals 5. So I'm going to say 5 is like right here. There's my dashed line. And I'm going to rotate it. So pretend that's a spindle, and you can rotate it. So let me see if I can measure this correctly here. Point. That's probably one of my better drawings. Maybe. No, not one of my better drawings. Okay. Looks okay. Does it look okay? Let's rotate it. So give it some three-dimensional. Oh, I like how it looks. I'm liking it. Look at that. It looks three-dimensional to me. The middle is hollow. Yay or nay? Yay. If I take a slice, I'm going to cut it right here. That's a dx. That's a dx slice, delta x, or dx is a better word to say. What shape am I going to have always, at all times, forever and ever? No. Let's start with a W. A washer. I am going to bring you guys holy washers tomorrow. Last year, when I gave them holy washers, we had 100% qualify. I'm not saying anything, but, you know. Yeah, I have holy water right there. Okay, here we go, guys. Here we go. We already know it's a washer. Focus, guys. We're doing pi big R squared minus pi little r squared. I have the pi factored out. We're okay? That's my cross section. So pi on the outside. Let me go back to red. Pi integral from what to what? 0 to 9, because those are all dx's. What is my big R? The distance from the sky blue line all the way to the x-axis. Look, let me go ahead and put it in black. This distance right here in black. Do you agree that's your big R? Yeah, I could have used the other one, but I want to use the original curve, so that's why I did this. So what is this distance forever all the time? 5, always. 5 squared minus my little r is from the axis of rotation to this curve. I'm going to use the original curve, not the reflected curve. Let me use burnt orange. This is my little r right there. Do you guys see that? Okay. So how do I get my little r? Don't make life hard. Think about it, guys. So let me go over here to the board. Okay. Look. At every different point, your radius is different. Way over here, the radius is 5, and the little r. And then as you get closer to here, the radius is whatever that is, 5 minus 3, which is 2. So how do I calculate that? Well, all I got to do is go from here to here and then subtract how much it went up. Do you guys see that? So I can just go 5 minus whatever that curve is. Cool or not cool? So as soon as I come back, you can put it back. Okay, you're good. All right. So parenthesis, and I'm going to write 5 minus the square root of x. Close it and put a what on it? That's your little r. And that's the only difference between axis of rotation and x-axis and y-axis is you're going to take the center, the axis of rotation into account. And you can always do it like that. By the way, I'm not done. I got to put a what on the outside? Dx. All right. I think that's all they wanted. So let's see. Letter A is out. Letter B is out. Letter C, 25 minus 5 minus square root of x squared. It looks like it's that one. Make sure you put a note that 25 is 5 squared. Yeah, that's it. All right, relax. I think you guys are going to love this, especially if you love drawing. This is coming from Delta, so I made sure to give them the credit. Find the volume of the solid obtained by rotating the region bounded by, so this parabola that you see opening up in the x direction is x equals 6 minus y squared. And then this line that you see is x equals negative y. We're still okay? And I'm rotating it about the line x equals 8. So I'm rotating it about right there. That's your x equals 8. So first, let's go ahead and just mirror the image. I'm just mirroring this part of it, the region that's bounded. So let's see, that's at 2 away, so I'm going to go 2 away. And then that's 8 away from the, oh, nope, that's 8, 9, 10, 11. 11 away, so let me see if I can do that. I'm just kind of eyeing it. What does it remind you of? Yeah, so then you're going to love this. All right, let's see what this is. Let me rotate it. Let me see if I can do it perfect. It's not perfect, but that's fine. It kind of looks like a fancy, one of those fancy coffee tables that you see in a bank. Now let me slice it. Where am I going to slice it? I'm going to slice it right down the middle. No, you can slice it wherever, but in this case I noticed that it doesn't matter where I slice it. It's gonna, no matter what, there's gonna be a hole in the middle. Actually, I was wrong about the shape. I said coffee table, but all that is blank. All that is void. Yeah, it's an inverted coffee table where you have nothing in the middle. It is. It is. Well, a weird donut with like. All right. You guys ready for this volume? Yeah. Volume equals. Before we start, I want you guys to recognize that this is a dy and not a dx. So let's see what's the lowest y value. It's this one down here, and that lowest y value is -2. What is the highest y value? It looks like 3. So pi on the outside, it's always those same two curves. So integral from what to what? Perfect. The big R. I want to use the original equation, so I'm going to use the one on the left, not the mirrored objects. Focus, Lavelle, focus. So I'm taking the axis of rotation. So here it is. From 8, let me change a different color. From 8 all the way to that linear line. No, it's always changing. Depending on what your x value is or y value is. Do I have it? That linear line is x equals -y. Yeah, no, it is. It's 8 minus y, or -y. Yeah, but I always like to show it like this. You can write 8 plus y, guys. And I know what some of you are saying, Chav, what if you're over here and the y is a negative value or whatever? Watch, if you're down here, it's a -2. 8 minus a -2, it's going to turn to a plus, and it'll be, well, hold on. 8 minus No, it's right. It's correct. It's always 8 minus your curve. Minus, parenthesis, and I'm going to write 8 minus, it's always 8 minus your curve. 8 minus, what's this quadratic curve? And make sure to end it with a dy. Okay, it works. It works. I was just freaking myself out a little bit with the 8 minus a negative y. All right, what's up?
So if the function is like symmetrical, why is it the integral from negative to why is it negative?
All right, hit me again, Kalani.
Since like the lines are like symmetrical, like along the x-axis.
Along the x equals 8, yes.
Why is that the integral from negative to negative two?
Not negative. Why is it from negative 2 to 3 and not like 0 to 6 or something? Or
Not negative two to two.
negative 2 to 2. Oh, because I'm doing it with respect to the y value. Negative 2. The y value way over here is 3, and I got to take all those slices. So I don't see it stopping at 2. Like it keeps going all the way to 3. Unless you were talking about x values or something, but I don't. Do you know what I mean? Yeah, I got to keep going all the way to 3. All right. You're okay to use a calculator. Just because it says negative y, remember it's a dummy variable, guys. So here we go. Pi, math, 9, from what to what? Negative 2 to 3. And then parenthesis, 8 minus, or I think we said plus, but that's fine. Parenthesis, negative x, close, squared, minus, parenthesis, 8 minus, parenthesis, 6 minus y squared. Okay. 6 minus x squared, close, squared. I hope I didn't do any mistakes, and let's see what I get. I got 785.398. How are we feeling? Oh, yeah, I don't have units. If it had units, you would put cubic units or whatever. Oh, we put the pi in there. We're okay so far? What's up, Ian? All right. What you are looking at is a real question from 2005. I have not, oh yeah, you guys weren't alive yet. I have not looked at the rubric yet. Let's see if we can figure this out. Let f and g, so they're labeling them, be the functions given by, and they give you f of x equals 1/4. By the way, it's a calculator question. 1/4 plus sine pi x, and g of x is 4 to the negative x. Let R be the region in the first quadrant enclosed by the y-axis in the graphs f and g. You can see it there. And let S be the shaded region quadrant enclosed by the graphs f and g in the figure as in the figure to the right. All right, Lavelle, focus. Find the area of R. All right, don't pick on her, miss. All right, here we go. I want to find this area. Before I can find that area, I got to find where those two functions what? Intersect. So put the f in y1 and put the g in y2. So y equals. Can you give me the equation again? It was 1/4 plus sine pi x. Plus sine pi x. And what was the next one? 4 to the negative x. Perfect. I just care about the first quadrant, so I'm just going to put my window to the first quadrant. I'm going to go 0 to 3 and 0 to 3. I might have to reduce it in a little bit. We'll see. Yeah, let me reduce it a lot. I'm going to go by 0 to 1, 0 to 1. 0 to 1, 0 to 1. Just to make it look pretty. And there, okay, I'm going to go a little higher. Luckily, it's not taking forever here, so we're good. All right, now we're good. It's still not perfect. I should have done 1.5, but I'm not going to mess with it anymore. All right, let's find that intersection. Second, calculate number 5, enter, enter. And I want this one way over here. I might have to get the other one too. Let's see. And I got 0.178218. Is that what you guys got? All right, so the first thing I would have done this. I would have gone in here. I would have said 1/4 plus sine pi x equals 4 to the negative x. This is called a setup. And then I would just say x equals, and I would just write that number down. And I got 0.178218. 0.178218. And you guys know my habit. I like to store that into what letter? A. So I put an arrow, and I like to say store into A. So that arrow signifies that you put it in A, and now you can use A as many times as you want. So I'm going to go to my calculator. I'm going to go second quit. I'm going to push X, and it better be that number. I check it. Yes, it is. Store alpha A. All right, here we go. How do I find this area? I'm going to integrate region R equals 0 to A. What curve is on top? Uh-oh, Chav, I don't know. Yeah, you do. No, that one's 4 to the negative x. What letter do they use? You can call it gx. If they don't use the letters to identify them, they would have said y equals, go ahead and put the expression. G of x minus what? F of x. And then close it up, put a dx. It's up to you if you want to use parentheses on gx minus f of x. You don't have to. And now, this is called a setup. I just write the answer. So I'm going to go, and I'm going to go math 9 from, I already forgot, 0 to A. And I'm assuming that I already have A in here. Alpha trace, I think the 4 to the negative x, I put it in y2. Minus alpha trace y1. And if you get a negative, that means you reverse them. 0.064 or 0.065. 0.064. You could also say 0.065. You know what? I like to put as many digits as possible. 0.064,753. If you put 0.065, that's perfectly acceptable. 3 digits after the decimal minimum. Are we okay so far? Okay. Letter B. Find the area of S. So it does look like I need to find this intersection. So I am going to change my window a little bit so I can see it, because at the moment it looks like this, and I'm kind of, it might be 1. It might be a perfect 1. We'll find out right now. So I'm going to change my window a little bit so I can see better. I'm going to put 1.5 for X max, and I'm going to put 1.5 for Y max so I can see it a little better. Yeah, this is perfect. It is a perfect one? Oh, dang it. Okay, it's a perfect one. Thank you, Ms. Wilson. Here we go. Region S is equal to, from what to what? From A to 1. Because you already identified what A is, make sure that it's in there somewhere, guys. If you're paranoid, you can put in here A equals 0.178218. If you're paranoid, go ahead and put it in somewhere in there, but it should be okay. We've done this many times. And then what curve is on top? So f of x minus g of x. Oh, I think you'd be okay. I think so, because there's no other way that we could have gone to 1. But if it's safe, as long as you're not, you see up here. Okay, actually, you brought up a good point. So let's say you're paranoid, guys. Remember when we did this step up here in A? You could have said this. You could have put both answers here. You could have put 0.178218, and then you could have also said x equals 1. Because that's the only time those two equations are the same. Does that make sense? Yeah, so you could have put that up on the top, but you're always safe. As long as you do not have incorrect math, you are safe. As soon as you start making stuff up, it's wrong. All right, so here we go. Let's type that in. What did you guys get? 41036. Okay. At least 3 digits after the decimal, so 0.410 at the minimum. Let's see what letter C says on the next page, and I put the picture there to make it easier for us. Oh, look at that. We have that question. We're rotating about a different line. Find the volume of the solid generated when S is revolved about the horizontal line y equals -1. So let me see. I'm gonna exaggerate it, and I'm gonna say this is y equals -1. Draw a picture to help you out. What region? R or S? S. Okay. So I'm just gonna mirror the S. So go to the axis of rotation and then try to make it like right there, and then that guy's super high. Right there. Not like that, miss. Come on, be appropriate. So it looks like something like, and then let me see. It goes. All right. No, it's not perfect, but that's fine. Okay. It looks okay. It's not my best drawing, but it'll work. What shape is that in red? It's a washout. I don't know why I said it that way. I'm sorry. Okay. And I can't wait to see this rubric. I haven't seen it yet. Yeah, because I've seen it. I saw it like last year, obviously, but I haven't seen it yet this year. In the years past, yes, of course.
Why did you lie to me?
Miss, I did not lie. I haven't seen it this year. All right, here we go. It's a washer, guys. Volume equals pi on the outside. Integral from what to what? A to 1. And now I need big R. The big R, let's focus, guys, focus. The big R is the distance from the axis of revolution all the way to the top of that curve. Yeah, you can do that. -1 minus f of x. Close it, put a squared. I know some of you are probably seeing it like, I think it's easier if you do f of x plus 1. It's the same thing, guys. You're squaring it. F of x plus 1 is the same thing as -1 minus f of x. Okay, because I see some of you. Look, okay, real quick, because I saw some of you the way. Look, you're right. The distance from the x-axis to that curve is f of x, and then that is the distance between the x-axis and -1 is 1. If you want to write 1 plus f of x, perfectly fine. I just want to make sure that I'm doing something the same over and over again so you guys won't get confused. So, are we okay with that? Are you guys okay with the -1 minus f of x?
Yes.
Okay. Minus, and then little r is minus g of x squared. Put a dx on it. Messed up. My dx is in there. All right. Do you have a calculator? All right, let's type it in. Guys, focus, guys. Try to do this, please. We have an AP exam coming up. Pi math 9 from what to what? A. Make sure that your A hasn't been erased. A to 1. Parenthesis -1 minus f of x, which was, I believe, in y1. Close it, squared. minus negative 1 minus g of x. And let's see what I have. 4.558. Was that the last one? Yes. Let's before we go to the next question, I want to see this rubric. 2005. This year. College Board. Question 1, right? All right, here we go. Look how they wrote it. Oh, I like it. They use little a. Lame. F and G intersect when x equals 0.178218 and when x equals 1. Okay, that's cool. Let little a equals 0.178218. We chose capital A, no big deal. Did we get, and look, they didn't even bother putting the expression, they just wrote g of x minus f of x. 0.064 or 0.065. We got 3 points. Letter B, from little a to 1 of f of x minus g of x, they got 0.410. That's the only answer that's acceptable. If you put 0.41, you lost the answer point because it needs to have that 0 there. Cool or not cool? All right. Letter C, they wrote f of x plus 1. It's the same as negative 1 minus f of x. You got the credit. So, Chuck, this is the only one answer they want. Relax. You got the credit. You got the point for the integrand. You got the 2 points. Did we get 4.558 or 4.559? Okay. Chav, why did you not write it this way? You can write it that way if you want, but I want to be, I want you guys to I don't want you guys to be thinking so hard. It just becomes automatic. But I don't want you to be a robot either. All right, don't be a robot. All right, let's go to the next one. I feel like we did this one. Or maybe. All right, let's see. Calculator. Okay, yeah, maybe we just did part A and not part B. Let f and g be the functions given by, again, they give us names, f and g, between 0 and 1. The graphs of f and g are shown in the figure above. Find the area, the shaded region enclosed by the graphs f and g. Give me the setup. Area equals integral from 0 to 1. What curves on top? F of x minus g of x. And close it with a dx. If you run out of time and you no longer have a calculator, the answer is always worth the least amount. It's only worth 1 point. This is probably, if it's a 2-pointer, that's probably 1 point there. If it's a 3-pointer, that's probably 2 points right there out of the 3. You know what I mean? All right. Do we know how to do that? Oh, you know what? Let's just practice anyways. Let's type in that into a calculator. I would type in f of x into y1, g of x into y2. Two x, 1 minus x. Three x minus 1 squared of x. Math 9, 0 to 1. Three, 3, 3? Okay. It probably goes on forever, guys. All right, guys. It probably goes on forever, the 3s, and I'm assuming that this 556 is just part of the tolerance. So it's probably 1.133333 forever, and that 0.556 is just part of the tolerance of the calculator. All right. Letter B. Find the volume of the solid generator when the shaded region enclosed by the graphs f and g is revolved about the horizontal line y equals 2. So here's my function. And I'm going to, look, that's the only picture I have. So I'm going to change that 1 to a 2. I'm going to go Did I freak out? Didn't everyone out? Or
Bro, we were like just copying the scale and everything. We're like, no.
yeah, like it's not gonna fit. Make it fit. Oh, what happened? Why did it do that? My laptop's been acting so weird. Maybe I got hacked. Okay, so here we go. No, it's okay. I don't have anything in here to hide. They can go through all they want. They can go through it all they want. You got permission, hacker. I don't got anything in there. I mean, I got nothing. I got nothing in there. If you want math videos and math, go for it.
It's like, let's say you could hear and be like, oh, I'm gonna get some good stuff on here. Open it, just.
Probably gonna be somewhere up there.
Oh, I don't know. I can't see a photo of it. Okay, the actual DVD part of it. Oh, yeah. I see it. Bro, look.
Man, Minecraft sucks.
It doesn't have to be that down. It's like that to scale.
Okay, well,
Kind of guess it. Not to scale.
I did get a D in art, so yeah. Yeah, I remember my freshman year, the engineering dean laughing at me. He knew me my name because of that, because I failed art. He's like,
That's also a super issue.
okay, what shape is that? Well, yeah, the cross section. It's a washer. So here we go. Let's see if we can do this, guys. Volume equals pi on the outside, integral from what to what? 0 to 1. And the big R is the distance from the axis of rotation to this curve down there. What do we say we can do? 2 minus g of x. But Chav, it's below the x-axis. It's okay because the y value is negative and it's going to be minus a negative. It's going to add it up and it's going to be a big number squared. Does that make sense to you guys? So yeah, so that way, see, no one gets tripped up anymore. Parentheses, what's little r? 2 minus f of x. And then what am I missing that you guys sometimes miss? Dx. If it's up to you, sometimes you guys are like, I need to put this parenthesis here. You can if you want. All right, type this in. Let's find this value. Pi on the outside. Math 9. 0 to 1. Parenthesis. 2 minus alpha trace y1, close it, squared. I feel like you guys are eating this up.
It's not bad. Yeah.
But are you eating? But are you cooking? Oh man, I messed up somewhere.
Job because you put 2 minus y1, it's supposed to be 2 minus y2.
Yeah. Yeah, make sure you don't get negatives. I couldn't remember what I put on what. Thank you, Guerrero. Look at you. I think you have a real shot of getting a 5, miss. That's the honest truth. No, I'm being serious.
I would say maybe a 3.
No. I think you have a real shot.
I'm a shooter. I'm not gonna say I'm gonna do it.
I think you have a real shot of getting a 5. I wouldn't tell you that if I didn't believe it. 1792. All right, let's look at this key. I feel like I didn't give you all the questions on that one. 2004, question 2. Why didn't I do letter C? Let H be the function. Oh, maybe because I just wanted to focus on A and B. Okay. All right, guys. So this one has 3 letters, but I didn't want to focus on letter C. I guess we don't have the experience yet, but we do. We have the cross section experience. Dang it, that's a lost opportunity. Maybe I just didn't type it next time. All right, letter A. Did we get 1.133?
Yeah.
Okay, so maybe I was wrong about that repeating decimal because usually if it's a fraction, they put it as a fraction. Letter B. Did we get 16.179? Look, I like how they did it. They also rewrote it in the bottom here. 2 minus g of x, 2 minus f of x. You get everything. 16.179. Yeah, we got everything. And then notice, look at the little note. If your functions, this is why I tell you guys to leave it with r squared. Note 0,2 of integral not of form r squared minus little r squared. Do you guys see that? So that's why even if it's a 1, and I know that 1 squared is 1, like I tell you guys, you know what? It's better to just leave the square there so the author can see there that you know it's a washer. Okay. Letter B. Oh, that was letter B. So we got 4, 5, 6. Yeah, open the door. So we just got 6 points on these free response questions. Are you guys getting better at these? Yeah. So here you go. On delta, don't worry. Delta is kind of lengthy. There's only 4 subtopics. It's a calculation that makes it lengthy. Look, here's what I'm going to tell you guys. Hold on, before you guys. Yeah, I already.